Hey, this is Mr. Hanson. I've got the beginning of a house of cards right here, and kind of interested in how to go forward with this. First of all, what kind of triangle would give me maybe the sturdiest house, and what kind of triangles can I make? So let's just look at these two cards here. And talk about this particular triangle. I'm going to kind of highlight it right here in yellow, something like that. So let's think about the sides first. What do you know about the sides of that triangle? Maybe you figured out that it must be an isosceles triangle, that two sides are equal because these two card lengths are congruent. So we know it's isosceles. Let's write that in. It's an isosceles triangle, meaning it has two congruent sides. What else do we know about this triangle? What do we know about its angles? Let's just kind of maybe number the angles a little bit here. So we've got A, B, C, D, E. So we've got several different angles there. What can we determine about A and C? Well, based on the fact that it's an isosceles triangle, we can use something called the base angles theorem to show that angles A and C would be the same. So let me kind of show why. I'm going to draw a dotted line right there, and if I were to fold that triangle over, it has some symmetry, and so angle C and angle A would happen to be right on top of each other. They would be congruent. So angle C is congruent to angle A. Now, what if we were given one angle measure? Could we find all of the other angles in this situation? Let's say I used a protractor to find angle A. There's a little protractor, and maybe this measured 70 degrees right there. So angle A, the measure of angle A is 70 degrees. Well, if we wanted the measure of angle D, think of your protractor there. We've got 180 degrees in the whole protractor. 180 degrees right there. So we've got, let's take away the 70 from the 180, the 70 that was in A, and we're left with 110 degrees. Okay, now let's figure out angle C. Since we said there was some symmetry here in an isosceles triangle, then angle C is congruent to angle A. And if those two angles are congruent, they have the same measure. So I'm just going to put in 70 degrees there. And then let's look at angle E. By the way, the M stands for measure of. The measure of angle E has also got to be like D, 110 degrees. Now we've got one angle left, that's angle B, and we can think of this in several, or a couple of different ways at least, but you may remember that there's 180 degrees in the three inside or interior angles of a triangle. So let's see how much we've used up already. We've used up A and C, that was 70 and 70. We used up 140 degrees. So 180 minus 140 leaves us what's left over, that's angle B. So that's one way of looking at it. You could also say angle B, let's do this, angle B plus angle C equals angle D. So this is called the exterior angles theorem. Angle B plus angle C equals angle D. Let's just see if it works. Angle B is, so angle B plus angle C equals angle D. Let's put some numbers in here for angle B. That's 140. Oh, wait a minute. Angle B is just 40. Sorry, that was my mistake. So 40 degrees there. And angle C was 70 degrees. And angle D was 110 degrees. So this is kind of an important relationship. It's called the exterior angle theorem. The two remote interior angles, B and C, add up to the exterior angle D. And it happens to work here. So there you go. My last question for you to maybe research is, what is the best angle to use right there to make a strong house of cards? Couple ways you could do this. You could do it experimentally and build some some card houses and see which ones you think are the strongest, or you could do a Google search and see if someone else has already done that. Thank you. Have a good day.